Hello, 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 everyone. Good afternoon. I hope you have a great time at TDC. I do. This is, I believe, my second or third time here and second time as a presenter. My great pleasure to be in Trondheim and present for such amazing group of people. And let's talk today about artificial intelligence, of course. And one particular place where we might want to have it, both as developers and as users. This is web platform. And let's talk about how we build it, how we can build it today and maybe tomorrow, and how to make it future-proof and standards-based and safe and secure for everyone. Before I ever introduce myself, let me run a short video with a quick demo I created and recorded, just to raise attention a bit. What you see on this screen now is right-hand side, this is web application itself, just runs in the browser. Left-hand side, this is task manager showing consumption of some resources, CPU, NPU, etc. And the task, what I'm going to run now is, these days we can call this trivial for AI. This is image classification, right? Just understand what's going on this particular, it's not a photo, illustration, and you clearly see it's generated by AI, and maybe not today's generation of artificial intelligence. This plane is, far from being perfect and maybe like technically incorrect. I believe when I generated this maybe like half a year ago, that was a totally different status of what we can generate now, both in photos and video. So, but that actually makes classification tasks a bit more interesting, right? So, can AI understand what's going on this photo that is far from being perfect? And quick set of parameters where you can choose which API to use for this classification, and also which particular device we might want to use for this classification. Let's run this. So I'm going to use WebNN, and I'll explain what this is all about, and NPU device here, and in just a few seconds, we'll see that, okay, it was more or less recognized correctly, right? So it understood that it's Wing, the most probability, airliner, space shuttle, tiger shark. Well, it says score 000, so it's like even less than, I believe, thousands parts of everything. I mean, it's okay, right? And of course, I didn't pay too much attention to the model that I use and the parameters, so it's more or less just as is, the simplest ever scenario. It doesn't matter for us in this context. What matters is what you see on the left-hand side. This spike, or a couple of spikes on the usage of particular device, that is NPU, or Neural Processing Unit. So two things here. That this video demonstrates that we were able to use this particular device, NPU, straight from our browser, using one particular API called WebNN. And I'll explain in just a few minutes what is WebNN and what is NPU, so we are all on the same page. And what's very important, this feature and this access to this particular device was never available before this standard appeared, and now we have the possibility to use this. And the second part, this is purely client-side application, and we could safely turn off Wi-Fi for this particular situation. And even though it's hosted on Vercel, thanks to the fact that this is a progressive web application, it's all pre-cached, so that you open this URL and everything works completely locally. Now, I'm Maxim Salnikov. I work at Microsoft here in Norway. I'm based in Oslo, and I love to build stuff, and I like I love to explain what I know, to share what I know, and especially I love to discuss all these potential features and the benefits and challenges, of course, and problems. And what's more important for this particular context, I'm proud member of Web Machine Learning Community Group that is part of W3C, World Wide Web Consortium. And this community group is focused on very particular thing, to make sure that machine learning and, as consequence, artificial intelligence are first-class citizens on the web platform. Something that we can run straight in the browsers, I mean us and our dear users. And let's start from where are we today. A couple of interesting things based on research, service, and just common sense. Folks from Intel did some research and say that we are actively use web. I mean, we as humanity, as people, as global population, as users of their devices, right? And we spent over half of the time doing something in the browsers. And if I remember correctly, this percentage is even higher on the weekends. Then, well, artificial intelligence is a prominent part of our life. This time, I believe we can all confirm that. And very conservative approach says that over 1 billion people on our planet are doing something with artificial intelligence. I mean, not obligatory as developers for sure, but as consumers. Devices are getting better and better. And like desktop devices, laptop devices, mobile devices, it's becoming kind of mainstream to have some special hardware support to do this inferencing or maybe even training tasks or fine-tuning tasks. I mean, that's a common trend that hardware is becoming cheaper, more affordable, and I believe today, more or less, kind of office-class machine, laptop, is pretty much capable to run lots of interesting things related to artificial intelligence. I mean, straight here, or what we call on the edge. We don't need to send this workload to data centers with super-duper chains of tens of thousands NVIDIA chips. No, we can do lots of things right here. As users, as consumers of artificial intelligence-based services, for sure, we want performance, we want our task to be completed fast, we want full privacy, and we don't want to depend on the connection, right? If we have capable device, why not to run all these things right here? Just to, as a good consequence of that, we are safe because no bytes of information goes somewhere on the cloud. And for sure, I mean, if we can get something for free, that's better, right? Because, for example, we already invested in a particular device that is capable to run something AI-related. So, yeah, why to pay for this or that provider of the large language model or API or something like that? Now, putting developer hat on, we love unified code bases, right? Write once, run everywhere, or something close to this, as possible. And for sure, like standards is all about that, right? And also, not all of us, talking about myself in the first turn, are data scientists and data engineers. So, for example, yeah, I know some foundations about how to train large language model or just language model, how to fine-tune that, but I'd prefer to stay on my own, say, comfort zone, at least now. I just want to build applications, kind of with some practical features powered by AI. So handy abstractions would be nice to have. All that comes to a very straightforward point. We need to run machine learning and artificial intelligence workloads straight in the browsers, because web is a great platform for all kinds of unification. Devices are good enough and will be better tomorrow and much better day after tomorrow. And yeah, if it's standardized, if it's not completely proprietary or platform-specific, vendor-specific, that's always the best. So this is why this standard appeared, WebNN or Web Neural Network network API. So it's here to solve exactly what I listed on my previous slide. It's quite performant. For sure, we can never achieve 100% what we can call native performance. Native, that means code that is specific for this particular architecture, platform, operating system, but it's quite good. So key metrics are like around 90% of the native performance. Of course, there is some kind of overhead when we propagate all this hardware capabilities to the web stack, right? But this loss is not that big. It can use different hardware, right? And we, to some extent, have control which hardware we prefer to use. And this is crucial because, I mean, applications of artificial intelligence are becoming that different. So in some cases, we want this particular task to run in the forefront with maximum performance, computational cycles, everything. Many of the tasks can be somewhere in the background, right? And I mean, it's not critical if, okay, they will take a bit longer to complete, but on the other hand, we will not drain our battery, and we'll still have smooth UI and running other applications. Unified abstraction, this is because it's a standard, and even though it's, I believe it's still draft, and it's for quite a few years in the draft, but if you know how standardization works in W3C, this is not something unique. I'd say this is a very general situation when standard that is implemented in the browsers, broadly adopted by developers, still in draft. That's things are normal. It knows nothing about the model. The model it works with, and with all good and bad sides of that. So it's quite generic in that sense, and we'll talk a bit later about what are, let's say, pros and cons of this approach. And also, very important point, this standard appeared not in a complete vacuum. This standard appeared not just in the heads of people who decided to create one more standard. No, it was based, first of all, on real use cases. I believe this is the next slide. And also in connection with what we developers already have in the web stack. I have a couple of slides on that a bit later. And yeah, basically the list of use cases is injected straight into this specification description. So if you open this specification, you'll find basically it's, I believe, one of the first sections ever. And it totally makes sense, right? We don't want to create standard for just have technical fun. We want to solve real practical use cases, and it's all gathered based on the conversations with the companies, users. So I believe it was nicely conducted survey, and I think that list of these use cases is ever growing. And as you can see, I mean, not all of these use cases are super exciting, like not everything is related to generative AI. That is basically default option when we ever talk about AI these days. No, many of them are something that we have for years as a part of hardware capabilities and native code. Now it's just time to take these very practical use cases and move them to web platform, thus to the browsers. Now about this layered pie of the whole stack of what we can call AI ecosystem on the edge. That means on the device itself, not somewhere in the cloud, not somewhere in not your own data center. All start with the hardware, right? And I'll say a few words on that a bit later. For us, it's important that we want to get access to the most complete list of devices that can ever run some AI workloads. Then layer of architecture-dependent, platform-dependent, operating system-dependent, what we can call machine learning APIs, like native ones. And of course, this set is very different for particular platform, right? Something specific for Windows, something specific for Mac, for Linux, for mobile devices. I mean, native developers have access to these amazing tools for quite a while, right? And they can build native applications on top of that. But we are here talking about web, right? This is why we need to propagate all these APIs and hardware capabilities to web stack, both to web browsers and more generically JavaScript runtimes if we want to build something on the web backend. Of course, for the developers, it's exposed as a set of web APIs. And WebNN, I mean, even though it's the latest here in this particular list, but not latest at all, and I will say about new approach at the very end of my session, it's not the only one, right? So we have WebAssembly, even though, I mean, for sure, this API, this technology was not specifically invented for running AI workloads in the browser. That works pretty good for this particular purpose. And same for Web GPU. Graphic processing units, they were not specifically invented to run AI workloads. They were invented to get maximum performance for the graphics, right? But it suddenly turned out that GPUs are great for calculating blockchains and also training and running language models and like machine learning in general. And maybe today this is kind of mainstream API that you see here and there if we talk about real applications already created for the web platform. And sometimes these APIs are too low level, and you will see this in example on one of the slides. So very smart and kind folks created frameworks, and for sure, I mean, all these frameworks are open source and free to use, and this is where exactly you get your own level of abstraction, I mean, own comfortable for you as a developer. That's really great because, yeah, to implement something very practical, as I mentioned earlier, you don't need to have foundational knowledge, like very extensive knowledge of how things work under the hood. You can focus on use cases, on tasks that always go on top of everything. Now, a few words about hardware. CPU, well, there is no device without CPU, right? So for sure this is the most compatibility, right? Not obligatory best-in-class performance, but good to keep in mind this as a fallback, right? Maybe not fastest, not most energy efficient, but if we still need to run something on this particular device, that might work. GPU, that's about throughput, right? It's maximum performance, maybe not really good for battery life if you talk about mobile devices or laptops, but this is where we can get the most out of hardware. And new kid on the block, NPU, Neural Processing Unit. This is, if GPU is, I believe, absolutely mainstream standard for all kinds of computational hardware like desktops, laptops, hard to imagine something without at least some form of specialized chip or part of chip as a GPU. Then NPU, something that is a bit still cutting edge, and I specifically asked this device, it's Microsoft Surface Studio 7 or something like that. And it has NPU unit, and exactly because of this fact, I was able to record this video I demonstrated at the very beginning. So what is NPU? First of all, it turned out it's not, in many cases, in vast majority of the cases, this is not even separate chip. This is just part of or integrated CPU, or I believe correct technical term, SoC, system on chips. I'm not hardware expert, but I mean, do not expect to point somewhere on the motherboard and say this is NPU. No, normally it's included somewhere in general silicon. And this is something that was specifically created for running these particular workloads, and it's much more generic, much more general than, for example, things we have in generative AI. As name says, it's basically to do something with the neural networks. And I mean, where generative AI is only one of possible applications there. And it's maybe not obligatory about better performance than GPU. So in that sense, yeah, I cannot say that NPU runs everything faster. That really depends on particular hardware, right? But it's for sure about two things. First of all, it's power efficiency. Definitely, if you run some AI workload that is, say, non-critical for your particular task, I don't know, some background blurring on the video call. You don't want to drain all your battery just because of this, right? And NPU is exactly about that. So it's optimized to run AI tasks in the background without too big impact on energy consumption, at least compared to GPU and CPU. And second, it's always good to outsource some tasks, for, like specifically related to AI, to dedicated hardware chip, right? Or like dedicated piece of hardware, just to make sure that, for example, GPU is fully responsible for doing what it was invented for, showing us some good pictures with maximum FPS and not spending some resources on AI, right? So I believe having NPU will become kind of mainstream also when we talk about hardware, right? I think if there are only limited models you find in the shops that are equipped with this part of hardware, I believe it will become very, very different in coming years. Okay, what do we have for us as users from this standard? And I think we can generalize this. What do we have for the users if we talk about running AI workloads locally in the browsers? Because WebNN is only a part of a very strong motion we see today that is called Web AI. And actually, last week there was a huge conference in States called Web AI Summit, like full day, multiple tracks dedicated to this particular topic, how we run AI workloads in the web. Basically, it means in the browser these days. Low latency, I mean, even though local hardware, of course, cannot compete with all these monster machines in the data centers, when we talk about some, for example, generative AI tasks, we still save some milliseconds or seconds, depends on network, from not sending our request somewhere outside and not waiting for that back. Privacy, yeah, we can safely turn off Wi-Fi and run everything locally. We do not rely on any kinds of third-party services, right? Again, maybe today is a good example. If you follow the news, you know that half of internet is a bit down because of one vendor. So it's not the case if we run everything locally. And for sure, we do not spend money on all these subscriptions. For the developers, we are at a developer conference after all. Get capability from the latest hardware innovations. So today we call NPU an innovation. So who knows what comes next after NPU? Maybe even more specialized piece of hardware. And if we have that specific standard, most likely this will support new hardware. Access to what we call, again, native operating system services related to machine learning and artificial intelligence. This is from like level above. Level on top of this, benefit from existing web frameworks. Again, back to the fact that this specification was created kind of considering what we have already, not to break, let's say, developer experience in that sense, or at least keep it as smooth as possible. And after all, it's a consistent and efficient system of running some stuff on the web. Okay, how do you start? How do we start with WebNN? Well, it's still a bit experimental, I'd say, so I do not expect production-ready applications, well, at least until next calendar year. And this is kind of optimistic approach, because this particular specification is not even in origin trials so far. It's definitely on the way there, but now you need to, first of all, use Canary or dev version of your Chromium-based browser, so it's currently for these two, and also enable flags. I mean, of course, that means that it limits significantly possibilities of testing how that works for the tens, dozens, thousands of the users, but hopefully it will end in origin trial soon, and then you'll just register this and add a couple of meta tags on your website, and magically it becomes available for all visitors of your website. And even a bit more complex if you plan to leverage NPU. So basically this becomes cutting edge of the cutting edge. So in this particular case, you need to install latest version of operating system, Windows 10 or 11, I don't remember where it started, most likely 11, and some particular edition of that is not that old. And most likely you need to update drivers for your motherboard, and here we talk about two particular manufacturers, Intel or ARM. So this one is ARM laptop with a Qualcomm chip. So a bit extra movements from your side, but again, that's your kind of time investment to the future, when first of all, majority of people will have these NPU-enabled devices, and of course, there is no need to do so many things before ever start. But imagine that you have your hardware completely ready for running both WebNN and optionally NPU, because I mean you can use WebNN successfully with your GPU, with your CPU, so there is no kind of, it does not dictate which device to use. Of course, I mean having NPU is always a good option, right? But when you start coding something using WebNN standard, what kind of web API is this at all, right? So what kind of primitives it exposes? Well, as name says, it's everything very low level, very generic, related to the neural network. So basically, using this specification, you as a developer, as JavaScript developer, has a chance to construct computational graphs. And you operate with such things like graph, context, operand. So basically, you construct this graph and then execute. And for me, honestly, that looks a bit like abracadabra, right? So I'm not a data scientist. I never constructed computational graphs, but I still want to use that. What if we go one layer above that, and maybe a couple of layers above that? So what if we still want to build web applications that runs in the browser, and we are JavaScript developers, JavaScript, let's say application developers, right? We can use then WebNN API as a backend for a couple of layers on top of that. And normally, it all starts with Onyx Web Runtime. I'll explain in a few seconds what that's about. And in many cases, you want to move further to even higher level abstractions framework like Transformers.js. And of course, I mean, this level distribution is very relative, right? If you say, for example, native developer that WebNN is very low level for you, of course, these people will smile, right? People who work with with binary codes, assembly language, etc., etc. So what is Onyx after all? Because most likely you will hear this word, this name very often, basically day one, when you ever start try building something with web AI using WebNN or WebGPU or whatever. This is format for the model. format that is very well adopted by key players, a format that has tons of converters back and forth to this format, from this format. And in addition to the format specification, it has set of runtimes for you to actually do something practical, right? To create models following this format and run these models. And as you see on the screenshot, these runtimes are available for pretty much all mainstream and maybe not even that mainstream platforms, programming languages, frameworks, etc. But what's interesting for us specifically, this is runtime for web, and it has like very non-exciting name, Onyx Runtime Web. And it's totally different story if we think what is the developer experience. You remember that WebNN is all about very manual construction of your computational graph, right? Here we, first of all, lock model format, so we have very concrete format of the model to work with. I mean, even though less flexibility, but much simpler for us to, for example, find these models, fine-tune these models, everything. Once we know which format do we follow, and we here have something like inference session. So it's still quite generic, right? It could be any kind of session for any kind of AI task you can ever imagine, but still much simpler to, let's say, keep this in mind when compared to WebNN. And also here, basically in Onyx Runtime Web, you can choose which API to use as a backend. And you set this in execution provider's setting. And yeah, you see, WebNN is one of possible backends for this high-level framework. WebGPU, WebGL, maybe you don't want to use WebGL. It's kind of predecessor of WebGPU, or WebAssembly for maximum compatibility. You can even choose device type and what kind of power preference you want to have for this particular workload. But again, this is still very generic inference session. It's not kind of practical, right? What if we move layer above and look at Transformers.js? It's very interesting layered pie. Transformers.js in its turn uses Onyx Runtime Web as a backend, and Onyx Runtime Web has possibility to use WebNN as a backend. So it's kind of, we do double jumps here. Why? To start, after all, reasoning about particular cases, particular tasks. And Transformers.js, folks, if you do web development, web front-end development, and didn't try this, my best recommendation, look at this, create something simple, something practical. You will be surprised how powerful Transformers.js and what great developer experience it provides. You see, I mean, it's a bit marketing-ish slide of this. It gives you possibility to basically achieve many things with language processing. It's multimodal, so it accepts both texts and images and audio and everything. And it's JS, right? I mean, it's kind of fork of Transformers framework, but specifically for JavaScript, not fork, but kind of rethink of that. And also recently, Transformers.js became part of Hugging Face that, if not guarantees, but I believe provides much better possibilities for bright future of this framework, right? It's backed by this large company and very, say, noticeable company in artificial intelligence discipline. So you get out of the box catalog, huge catalog, and ever-growing catalog of the models ready to go for your tasks, right? And all hosted on Hugging Face, of course. And some of these models are specifically optimized for WebNN if you want to use this API as a backend. If you wish, for sure, you can always create and serve your own model, and you can and downloading of the model, for sure, I mean, here we talk about some time needed, some bytes, megabytes, sometimes gigabyte needed to have this model ended up on the edge device, right, of us or our users. And yeah, this is kind of a drawback of using web AI on local device, right? These models are not obligatory very small these days, but at the same time, this is kind of one-time operation in this particular situation for your particular origin, for your particular website, and downloading and caching and storing this on your device from developer experience for Transformers.js is just seamless. You don't need to write any kind of code, but at the same time, you have full control on what's going on with download and what happens with this model next. And as I mentioned, this is task-based. So here we start talking about very concrete applications. For example, if we want to run sentiment analysis, we create respective pipeline and run this. So basically 2 lines of the code plus import of these tasks, and we have something running immediately. And under the hood, framework is downloading model. I mean, of course, in parameters, we can choose which model we prefer, our own or from the catalog, us to decide. And there are a bunch of these tasks available right out of the box. Text, vision, audio, multimodal experiences, basically everything you can ever imagine, what you ever need to add to your application. So, summary for this particular case, and we have 3 more minutes for second option that I want to tease a bit. Web standard for running AI and machine learning in your browser exists natively. And currently, WebNN is the only way to use all hardware spectrum, including NPU, in your browsers. It's still moving standard. Still, some parts might experience changes. So recent one was device selection was removed from specification. So it was kind of outsourced to higher levels. And always think about user experience, right? If we are talking about downloading something before starting to use this, inform your user and of course provide all possible offline experiences. Demo repos are available both for Angular and React with Next.js setting, but I used these frameworks mainly just for UI level. The code itself is very just vanilla JavaScript. But what you can get from these repos is how we outsource everything to web workers, because this AI inference might take some seconds, and you don't want to have your UI freezing during this time. So create web worker, run this workload there, and then send a message back when it's done. Now, just a couple of minutes for this one. And this is, I don't know if I still should put new here or not. I mean, these days, definition of new is changing, right? What was new a couple of months ago, it's now like old news, right? But maybe you still didn't hear or didn't try that. Totally new way for achieve the same running AI workloads in your browser. But now it's not about using let's say it's simplified way, not that flexible, but when you don't ever need to think about which model to use, how to download this model, and this is like once you don't need to think about that at all. This is just part of the browser itself. And it's currently available for Microsoft Edge and Google Chrome. I believe other browser vendors are considering adding this. At least I've seen open issues in respective repositories. So idea is the same. It's API for developer, but of course like very restricted APIs in number of tasks. So if WebNN is as generic as possible and only on like Transformers.js level you have these practical tasks, here it all starts with practical tasks. You'll see a list in a second. models is built in the browser. You don't even need to sync this. But of course, also like you lose flexibility here, right? So what a browser vendor considers as a model for this browser, you always kind of live with this and your users, right? So, and obviously, these are different models for different browser vendors. For Google Chrome, it's currently Gemini Nano. For Microsoft Edge, this is Phi 4 Mini. But on the other hand, you have much simplified experience. And code looks like that. You have a set of objects like summarizer, writer, translator, prompt that are just part of window object in JavaScript. So it was initially part of window.ai object, but it was generalized, simplified. And, well, you just write a couple of lines of the code, and it just magically works. I'm not saying about status of availability of this prompt API and writing assistant APIs, because they are different from browser vendor to browser vendor, from API to API. But last time I checked, majority of these task-based APIs were part of origin trial. That means that, again, you register your origin in respective form, and it put meta tag, and it becomes available for all your users. So it's a couple of steps ahead compared to WebNN in terms of like how close it to production. On the other hand, I mean, it's faster in that sense, but slower in adoption by Worldwide Web Consortium. So it's not official draft of that yet, but the interest is kind of under consideration here. How to start with this prompt API and write assistance? There is a playground. All starts with real-life use cases, and since this is moving standard, like WebNN, feedback is appreciated. And of course, I mean, I have few links on that deck, and how to get this deck immediately. Very simple. This is my last slide. This is my LinkedIn profile. Scan QR code, find me, connect me, follow me, you prefer, and ask for this deck, ask for support with WebNN or Web AI in general. And I normally post about all these updates on my feed, so if you wish to stay connected with that part of a technical story, follow me. Thank you so much. Tusen takk.